In this video lecture, I will introduce the idea of using definite integrals for tasks other than finding the area under the graph of some function. And these applications arise from the following idea. So if we recall the definition of a definite integral, so we say, hey, the area under the f of x on the interval from a to b can be found as a limit of a Riemann sum that we write like this. And we know that xi star is just some representative from this interval, and we know that the first value is a and the last value is b. And we're going to look at this formula, and on the one hand we're going to accept this as the definition of a definite integral. On the other hand, we're going to flip the sides and say that, hey, well, it works the other way too. So every time I see a limit of anything that looks like this, that doesn't have to be, but if can be interpreted as a Riemann sum, then such limit can be evaluated as a definite integral from a to b of this function, whatever this function is in here, with respect to x. And we're going to have this understanding that the a and b are somehow defined in that Riemann sum formula, or what appears to be the Riemann sum formula. And it seems like a very simple idea, but now we can actually do applications that have nothing to do with the area of a function under the function on some interval. So for example, if you anywhere in the future will see an expression like this, and somehow, again, I'm just going to write something which may look crazy. This is x star squared. And if somehow we have an understanding that x0 is 0, if somehow it's communicated to us, then we're going to look at this expression and we'll recognize that, hey, this is just an integral from 0 to 1/2 of the following function, and we're going to be able to extract this function from that sigma expression. Similarly, if I'm going to let you guess this one, so if in the near future, let's say you were to see something like this, oops. And let's say it is somehow clear that x sub 0 is 0 and x sub n is 2, then what would this be equal to? Well, remember, the pattern is that whatever is between delta x and sigma is what we're going to integrate. So in this case, we would write that as a integral from 0 to 2 of square root 1 plus f prime of x squared dx. And with this simple idea, we will be able to tackle a few interesting applications, such as finding arc length, finding the surface area of solid of revolution, finding work done by some force, and many others.